Recording. Good. Yeah. So last week we had sections 3.1, 3.2 in a video. We took a test since then, so some of this may have washed away. But we came up with two formulas in section 3.2. The first one was S equals theta R. And for those of you that watched the video, S stands for what?
Angular spit.
No, I'm not sure what you said. S stands for arc length. Okay, we had a formula for arc length was the distance moving around the circle. And one of the special notations we had to make was S being arc length, R being radius, theta had to be what? R word.
Radians.
Yeah, theta had to be in radians. So in both of these cases, it was radians. And you saw how we started with circumference equal 2 pi r. And this guy over here, area of a sector, had sort of the same kind of development or history where it was the pi r or 2 pi r squared for the area. And we had to do area of a sector. We made some adjustments. So these two formulas were what you should have gotten out of section 3.2, along with how to convert degrees to radians. So taking a look at this first problem, we have the distance between city E. Okay, first of all, assume the cities lie on the same north-south line and that the radius of the earth is 64 kilometers. Boom, I'm writing down radius is 6,400 kilometers. Got that. I draw the earth. Here's the equator. City E is 35 degrees north. City F is directly south of it to 44 degrees south. So when I take a look at this, I have a radius of 6,400 kilometers. I have a theta of 79 degrees, and I want to know how far this distance is, which is my arc length. So I'm going to say S equals theta times R. Thing is, though, I cannot use 79 degrees because theta has to be in radians. So section 3.1 was taking and doing a conversion between radians and degrees. And what fraction would I use here to do this conversion? What radians equals what degrees?
Pi over 180.
Excellent. Pi over 180 degrees. They were the same because we learned that 2 pi and 360 were the same. So now in order to convert this to radians, I'm going to have to, calculator help, I'm going to say 79 times pi times 3.14159 divided by 180. So now I get 1.378. The more I go decimal places, the better. So that's what this theta equals. When I did the work on this, I got this radians times 6,400 kilometers. And I should have gotten, let's see, times 6,400. Oh, I don't need a minus sign. Equals times 8824 kilometers. Any of the groups get that? So that was a bunch. That was 3.2. And it sounds like one or two of you thought, yeah, I don't need to watch that stupid video. And you may have skipped out on that. Taking a look at number 2, a bicycle wheel with a 26-inch diameter. Okay, that means there's 26 across. Right away, I know everything I'm doing with here is dealing with radius. So my first thing I'm going to do is I always try to draw pictures when I can. And if the diameter is 26, I know the radius is 13 inches. Okay. Travels a distance of 200 feet. That means 200 feet went around the tire. 200 feet. Because if I think about it traveling, and this is rolling 200 feet, that would be the same as 200 feet going around. So the 200 feet is actually going to be my S. 200 feet. Again, I'm writing everything I have down as I go. How many revolutions? It must have been so a revolution is one time around. So I have a new note to make. One revolution equals 2 pi. So how many revolutions is really going to be, how many times around did I go? How many angle, did I go around? So I start with my formula. I go S, which equals, I got that as 200 feet. I think I need to keep an eye on something because this is 200 feet and this is 13 inches. So now I have to decide, okay, what do I want? Feet or inches? Which one should I work with? Anybody?
Feet.
Feet. Okay. So 13 is the same as, let's see, 13 divided by 12. I'm going to change that to 1.083 feet. 1.083 feet. All right, so now I'm going to use this S equals theta R because I want to find theta, and 200 and okay times 1.083. It's all in feet. So I'm going to divide 200 divided by 1 point. That's not right. 1.0833333. And I get, once I divide, I get a theta equals 184.615 radians. Okay, so it went 184.65 radians. Well, the question asks, how many times did it go around? So in order to find the number of times going around, what am I going to do to this 184.615 radians?
Divide by 2 pi.
Yeah, I'm
Yeah,
going to
just-
divide it by 2 pi. Excellent, because that's radians. So on my calculator, I'm going to hit 2 or divided by parentheses 2 times. Oh, I see pi over there. I have to hit second and that. Okay. And so I'm looking at 2 pi because I found pi down here. Pi was above this, the caret right there under the word clear. So when I hit enter, it's going to go around 29.338 times. Cool. Yes, and I'm going to start watching car tires and bike tires and bigger tires that are on a truck that aren't supposed to be on a truck when you have a smaller tire to start, and then it messes up the odometer and on and on and on. I'm going to skip 3. I'll let that one for you. I'm going to take a look at 4. 3 was another one with arc length, but number 4, where are we at here? I can see that. Number 4 says, find the radius of a circle with a central, all right, I need R equals what? Find the radius. And I say a central angle, and that's going to be my theta. That's my angle. And radian determines a sector of area 93 square. So what I'm actually giving here, the area of, and a lot of times people will put that lowercase s to recognize sector, but the area of the sector is 93 square meters. So what does it look like I'm going to be calculating? R. So now I need my formula. Area of a sector was pi r squared over 2. Okay, so this is 93 square meters equals pi r squared. Looks like I'm going to multiply by, what am I doing here? I messed something up. Oh, what did I forget? I even forgot it in my formula. What's the area of a sector? All of a sudden I'm going, okay, I think I messed that up. So now I have to go correct it. Let's see, the area of a circle was pi r squared. And when I worked on this, I went 2 pi r squared divided by 2. I multiplied top and bottom by 2. And then I replaced the 2 pi with theta. So when I wrote my formula up above, I put in a pi instead of a theta. So I apologize for that. So the area of a sector is theta r squared over 2. So it's going to be area of a sector is theta r squared divided by 2. So it's going to be 93 times theta, which is pi over 3, r squared times divided by 2. Sorry about that, folks. Oh, 93 times 2. I get 186 equals pi r squared over 3. Looks like I'm going to multiply that by 3 now. 558 equals pi r squared. Now I'm going to divide that by pi. 177.616. So I need to keep this side. That was where I came up. Yeah, I messed up. I said pi up above. I apologize for that. So now I have 177.616 equals r squared. Now I'd like to take the square root of that number. And I see that second blue again. So I want to take the square root of that number. I hit second and then came down here to x squared. So I had that. And now I'd like to grab that answer instead of typing it in. And down here in the bottom, it's answer. So I'm going to hit second, that minus sign, and you notice how it puts square root of the answer in there. So when I hit enter, I get r equals 13.3. And yay, A was an answer. A was one of my choices. Whoop, whoop. This answer is A as well. Questions? Because I know y'all don't ask questions, and then you don't know how to do something, then you take the test, and then I find out that you didn't know how to do it. But you won't ask the questions.
I have a question
Yes.
for like, for number 3, would
Mhm.
we, I mean, I guess we could get the right answer, but like, so for number 3, like the circumference of a circle is 2 pi r, right?
The circumference is 2 pi.
R.
No, okay. Circumference, this was our problem here. Right? This was the diameter. I'm sorry. Yeah, you're right. Circumference is 2 pi r. Diameter is 2r. So circumference is 2 pi r. Yes, sorry about that.
So, I mean, would we be like allowed to solve that on a test by just doing like 2 pi r? Like, wait 1 second.
Okay.
So it would be like x times 2 pi r equals 200.
So, all right, let's take a look at it. S equals theta r. Okay, that's the distance traveled. That's my arc length. Suppose the tip of a minute hand of a clock is 5 inches. So I know my radius equals 5. And I know to be careful. I'm going to make sure I write inches because we did see a problem a moment ago where that was a potential problem. Determine the distance traveled by the tip of the minute. That means I want to find S. Okay, I know R, but it looks like the minute hand in 3.5 hours. So 3.5 hours means that minute hand went around 3.5 times. And I'm saying that's going to be times 2 pi. Because every time around is 2 pi. So this should end up equaling an angle measure of 7 pi. So that's going to be my theta over here. Theta equals 7 pi. So now when I
For some
find-
reason, I was looking at I was looking at the wrong problem when I gave you the numbers. Yeah, never mind.
Gotcha. So then simply theta times that is 35 pi inches.
Yeah, all right.
All right, I'm going to leave number 5. I strongly recommend you do number 5. There's a good chance you'll see something like that on the test. Really? Yes. No. Yeah. Okay, good. Section 3.3. We've talked about a bunch of things in 3.3, and this is good to try to, we learned this. Let's keep bringing them back together again. We learned this, bring them back together again. So from 3.2, we're happy. There's my arc length. S equals theta R. Area of a sector written correctly this time. Area equals theta R squared over 2. And we learned how we develop those. We come back. If I have a unit circle, that means I have a radius of 1. If I have a point on the circle, like X, Y, keep that noted, because if I have a point on the circle, earlier when we were talking about our angle measures, we said sine equaled, so opposite over hypotenuse, Y over R. But if this is something called the unit circle, that means my radius is 1. So the sine of theta is going to be whatever Y is. Again, this is on the unit circle. The radius of this circle is 1. There's a lot we can learn from the unit circle. By the same reasoning, we were dealing before, we had that triangle and we drew it. And this was X, this was Y, this was R, and that was theta. So when I said the cosine of theta, it was adjacent over hypotenuse. But if I'm on the unit circle, this point X is going to be just whatever the cosine of theta is at that location. We know if it's a unit circle, by the Pythagorean theorem, x squared plus y squared should equal 1. Again, I'm just making a note here. The x and the y, if I know the angle measure, I can find that point xy because of taking the cosine of theta and the sine of theta. And of course, this ties right back into my Pythagorean identity. Sine squared plus cosine squared equals 1. Okay, so talk to me now. I'm sure some of you just heard me go, wah, 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 wah. So every radius on this circle is going to be 1. So X is going to be here, Y is going to be here. So a little note is, well, if this is the unit circle and that's 1, my X has to be smaller than 1. And my Y has to be smaller than 1. And remember a moment ago, we were saying that the X and Y are really like the ordered pair, cosine theta. So the ordered pair, X, Y, is really the same as the cosine of theta, the sine of theta. So a moment ago, I started saying, well, if R is 1, both the sine of theta and the cosine of theta, their values can never be bigger than 1, or by location, negative 1, depending on what quadrant the point is in. So we just have a little note for the sine of theta and the cosine of theta. Their range values are between -1 and 1. Okay, that was a lot. Above this pencil line, that's a lot of stuff in there. Hopefully you tied it all together and it's clear as mud. All right, well, let's stick with radians and do a little more work with radians. Let's try one or two of these. The cosine of 7 pi over 4. I'm just going to go back to section 3.1 and say 7 pi over 4. I'm going to convert that to degrees. So up here is going to be degrees, 180 degrees. And I know that's the same as pi radians. Again, from 3.1, you learned that if there's no label written, the default is radians. So this is radians, and the radians will clear. Pi and pi cancel. 4 goes into 180, 45 times. 7 times 45, 315 degrees. So now I want the cosine, and I go back to drawing a triangle of 315 degrees. That's going to give me a reference angle of 45 degrees. Building on something we learned before. 1, the square root of 2. But by location, -1. Now I want the cosine. Adjacent, 1 over the square root of 2. So this guy is going to equal 1 over the square root of 2, or we know to rationalize it and get the square root of 2 over 2. Yeah, I remember how to do all this. We just did all that, and we just keep building and building and building. This guy, I want the sine of pi over 2, or 2 pi over 3, excuse me, 2 pi over 3. And again, this is that more good practice, 180 degrees over pi, looks like it's 120 degrees. And I can do the sine of 120 degrees. That's over there in the second quadrant with the reference angle and so on. Uh-oh. -5 pi over 3. Again, I'm not completing these two. I didn't circle an answer or anything. I just did the conversion and said, oh yeah, the rest isn't too bad to finish. Over pi. The pi's cancel. The 3 and 1, that's 60. I think it becomes -300 degrees. But I also know that the -300 is the same as 60 degrees. So now my problem, I convert to be able to work with the tangent of 60 degrees. And as some of you found out, you can't do that on the calculator because the directions would say, find the exact value. Find the exact, and putting it in the calculator, that didn't work. Find the exact value. Why? Because we can draw the triangles and get the exact value for this. All right, so I'm going to throw a curveball at you. What if I said you didn't have to find the exact value? Find it, calculate the sine of 2 pi over 3. Well, I need to do this first. if I'm going to do the sine of 2 pi 3 and not make it degrees, I'm going to have to hit mode. And in my mode setting, I'm now going to come down and convert my trig to radians. To radians. So now if I really wanted to, I could find the sine of parentheses 2 pi divided by 3. So if it doesn't ask for the exact value, I'm able to switch it to radians, my mode to radians, and I would be able to find an answer, 0.866. Okay. By using the calculator. So now when I look down here, I start to see more radians. What's the cosine of 1.85? The cosine of 1.85. Negative 0.275. Again, this is radians. Just a reminder, this is radians, 1.58 radians. So if I was looking at my circle, you know, and if I go all the way around, I'm saying, oh yeah, that's 360 degrees. But I'm now also saying it's 2 pi. And if I look at that on a calculator, 2 times pi, I get 6.283. 6.283. So as far as radians go, I start moving and I go around. That's 3 radians, just a little over 3 radians to get to this point. This is a little over 1.5. So 1.5 radians is up in here somewhere. 1 radian is over here. Okay, and we could find out what 1 radian is as far as degrees. It's about 60 degrees. So as much as 360 degrees roll around, radians roll around. We talk 2 pi most of the time, but it does have a numerical value. Cotangent. Uh-oh. No, don't panic. That's going to be the same as 1 over the tangent of 1.3209. So, you know, on the calculator, I could find this, the tangent of 1.3209. And then I'm going to learn something I learned today. 1 divided by second, and all the way at the bottom was where I got answer. And if I hit enter, I get 255. 3 decimal places is pretty good. Correct answer, so I'm going to write that bad boy down. Questions?
What was the value for the one that's like under your calculator?
For this one,
Cosine 0.514.
okay. I never ended up even doing the cosine of 1.85. We just talked about this part. So if I wanted, let's do the first one, the cosine, and remember, I'm in radians. So 1.85 is what I can enter. Negative 0.276 equals negative 0.276. Final answer, I'm going to box that in. The second one, the cosine, 0.514. Enter. 0.870. Not 0.871. We round up. 0.871. Does that help, Ethan?
Yes.
Cool.
I have a question.
Yes.
What was with the can you go over the picture you drew if we're just plugging it in the calculator?
Okay. So this was just like a side note. And I had a side note of, you know, we talk about a circle. And when we go all the way around our circle, that's sort of a balloon that someone's had on, it's 360 degrees. Okay. And I know things like that guy right there is 60 degrees, that angle measure. Okay. And we also know that all the way around is 2 pi. And I can convert this, you know, and I know that 60 degrees equals pi over 3. That was part of that video the other day as well. And this is pi over 3. But on a unit circle, if I have 2 pi, my circumference is 2 pi r, where r is a radius. And if it's a unit circle, the radius is 1. So the circumference going all the way around will measure 2 pi.
I got you.
So if I,
And typically with all these, we're working with a unit circle, right?
yeah. And I know 2 pi is 6 point, what number was I saying? 283. So if this was 1 inch, okay, which is what we're talking about, 1 inch on a unit circle, this all the way around would be 6.283 inches.
I got you. Okay.
Yeah, good. And again, 1 inch may go to about right there. That 1 inch kind of idea. That was something different, a little confusing, but we sometimes need to think of it not just as that. Google unit circle chart. This is what I got, and I printed it out. So if you ever need it. Now, I've tutored and helped students in high school, and they told me, my teacher said we have to memorize this. I'm like, oh my gosh, good Lord, no, you're killing me. What you need to know is this: 30, 60, 90, and that this is 1 square root of 3 and 2. And the other one is my 45, 45, 90. That's 1, 1, the square root of 2. And if you have that, instead of me saying, what is the, okay, little quick review. In my unit circle, this is the cosine of theta, the sine of theta. So if I said, what's the cosine of 60 degrees? You would say 1/2. Or if I'd say, what's the cosine of pi over 3? You would say 1/2. To me, I say draw it, what location am I in with my reference angle, write the values in, and you can come up with it by knowing these versus memorizing this. Has anyone in here been told to memorize this back in high school?
Yeah, we
Yes.
were made to memorize it. We were quizzed on it too.
Yeah. So I think you need to be able to calculate it, something along these lines, because everything comes from this. If I said 150 degrees, what's the cosine? Well, you would come here and say, wait, that's a reference angle of 30 degrees. And you draw your triangle and do your 1 square to 3. There's all the numbers. To me, it's easier to draw them instead of memorizing this.
This helped me understand better than before. My teachers just tell me just memorize them.
Yeah. No, this is it right here. Because if I said, what is 240 degrees? And I'm going, I don't know, but I know that this is 60 and this is 30. So it's 1 square root of 3 and 2. That's a negative, and that's a negative by location. So if I come back over here to 240 degrees and I want the cosine, I'm doing -1/2. Whoop, there it is, -1/2. If I wanted the sine, opposite over adjacent, there it is. So I can draw them instead of taking the time to memorize them. But I wanted to tie it into, you probably saw this in high school. These are the ordered pairs. They're the cosine and sine of, in this case, 60 degrees. And yeah, oh boy, oh boy, oh boy. Let's get started on 3, 4 and see how far we can get. 3, 4 sure looks like a lot of word problems. And I lost my notes. Or where are my notes? There they are. Section 2, excuse me, 3.4. There it is. Oh boy. Oh boy, oh boy, oh boy. So in 3.2, we had the arc length. Okay, and we had the area of a circle. Two formulas, we have them, they're all good. Section 3.4, we're going to continue on with this idea, and it's similar but a little bit different. We're going to talk about linear speed. So if I have a point on this circle, how fast is it moving? You know, I'm going to be able to measure the distance by S equals theta R, but how fast is that point moving? That's called linear speed. And then I'm going to have angular speed, and that's going to be this guy right here. How fast is that angle changing? And these things are going to all be happening in terms of time. The change in distance over time, oh, that's a key word. Change in the angle measure over time. So again, P is a point. It's moving along the circle at a constant speed. R we're familiar with. That's just my radius. O is that center point. This is some of the, this section is one of the harder sections we've had or will have. So I'm going to try to make this as clear as possible. All right, so the first one, my linear speed. Linear speed is the rate at which P is changing. The rate at which P is moving along that circle. It's called the linear speed. It's going to be represented by the letter V. Excuse me. My V's, I put a little tail on so I know they're not U's, so I don't mix them up ever. So V now stands for linear speed. Now, where does it come from? Going to take it back just like I did circumference and use that to get arc length. And I used the area of a circle to get area of a sector. I'm going to take this to, let's start with distance equals rate times time. Well, if I divide both sides by time, I get rate equals distance over time. And that's what my linear speed is. It's my, how far did I go over how long of a period of time? So this rate equals this. So the linear speed, which is this rate, I call V. My distance, I already know what the distance is, right? That's S, that's my arc length. So that's S. And then my time is T. So in order to find linear speed, V, I'm going to use arc length over time, distance over time. Okay. One of the things to note is S is also the same as theta R. So I'm starting to get some variations here, which are going to help me depending on what information is given in my word problems. Good. Distance equals rate times time. Rate, I'm just going to bring time over, is distance over time, arc length over time. I also know arc length is theta R. So again, depending on what I'm giving. So I have another formula. Everybody got where it comes from? Check out it. Give me one thumbs
Yeah.
up. That's all I need. Oh, Ethan, you were going to say I got it, right?
Yes, I said yes.
Okay, excellent. So
I
that's
have a quick,
yes, yes, please.
when in your little drawing there, and you said center is that 0 or theta?
Oh, I just called it O.
Okay,
What if I wrote O like that? Does that help?
thank you.
Oh, it's O. Okay. Next one. The measure of how fast the angle is changing. Okay, the angle. Some of you should remember that we can call it angle POB or BOP, that kind of idea by using the points. So that's why the B is there as well as the O. The measure of how fast angle POB is moving, it's called angular speed. So just like up above, my linear speed was length over time. This guy, angular speed, is going to be the number of radians over a certain time. So we have W equals theta over T. Cool. Seems kind of clear, right? All right, until we do a problem or two. Now, I started to make some notes. I have S equals theta R, arc length in terms of radians. Linear speed was distance over time, the change in distance over time. Angular speed, W, is equal to the angle measure over time. So they're my three biggies. Now, I also, I took this and said, wait a minute, V equals S over T. So I started goofing around. V equaled S over T, right? And then I went, well, S is theta over R. And then I went, well, no, wait, W is theta over T. So, oh boy, I have V equals WR. So I came up with something like linear speed equals angular speed times the radius. Never would have thought that sentence made sense, but I did a little substituting. I started with linear speed equals arc length over time. Arc length is theta over R, but that theta over T, the theta over T here is like the theta over T here. I could replace that with W and come up with another formula. But these are the three I really want to start with. Oh boy, let's see what we got. We got that, we got that. I have notes everywhere. I want to keep this with this. And now I want to take a look at a couple of problems with section, 3.4. My answers are B, C, D, a C, a D, a BAB, BAB, B, A, B, a C, and a D. So I was sort of just stalling a little bit for time there. And let's see if we can do a couple of these problems for 3.4. As much as I would love to put you back in groups and send you off, sometimes that's not the easiest thing to do because you're still not turning on your cameras. You're still, some of you are just sitting there not saying a word, being a freeloader and so forth. But let's see how many of these we can do. Section 3. I want to go this way. There we go. Section 3.4, number 1. Notice I'm doing these in pencil so I don't mess them up. Oh, wow, this is almost a little too easy. Use the formula linear speed equals the change in angle over time. Okay. And I'm given that W equals pi over 8 radians per minute. And one of the things I really have to be careful with here is going to be my labels. I want to make sure they always work out. Equals, I have theta over T, which is 11 minutes. Okay. I'm going to get theta alone. I'm going to multiply both sides by 11 minutes. Theta equals 11 minutes times pi radians over 8 minutes. The minutes cancel. I'm left with an angle measure theta that is 11 pi over 8. And again, I don't have to put the word radians in. If I don't, that's the default. And it does match my answer, 11 pi over 8. It gives me the exact answer.
What's that word beside the 8?
It was minutes, but I have minutes in the numerator and minutes in the denominator, so they canceled. So I'm keeping my labels consistent when I'm doing these.
All right.
Shall we try number 2? Use the formula V equals RW. And this was that one that I ended up deriving, right? Linear speed equaled radius times angular speed. Yes, Chow.
Yes, when we doing the test, for example, when we doing the test, so depend the question, they say use the formula and we could use this one, right? Or we just figure it out by themselves. But
There may be some that say use the formula, and then there's going to be some that you come down here and it doesn't tell you which of the formulas to use. So that's going to be one of those things that I'm thinking when I get ready to take the test, I'm going to go S equals theta R. I know that. B, my linear speed, the formula for that was distance over time. Distance over time. W, my angular speed, was my angle measure over time. So I'm starting to write a bunch of things down that I'm going to need. You know, I didn't have to try to cheat and do, I know what they are, so I write them down right away.
okay, that's for me easy to figure out how. Okay,
Yeah.
thank you.
Mhm.
Thanks.
Anybody get an answer for number 2? Let's see. Here's how I'm going to do problems later. So I'm going to start doing it now. V equals 12 feet per second. What else do I know from this problem? R equals 1.6 feet. And I'm given the formula V equals RW, and it would like me to round to 4 decimal places. Okay, so it looks like the question should be asking to find the value of the missing variable. The missing variable in this case is W. So I have 12 feet per second equals 1.6 feet times W. I'm going to divide by 1.6 feet, but over here I'm going to write 12 feet per second times 1 over 1.6 feet equals W. You know, we're used to dividing, but I want to keep my labels. So I'm just multiplying by the reciprocal. Just like I canceled minutes up here, I'm going to cancel feet here. There goes a foot, there goes a foot. So it looks like I'm left with 12 over 1.6 seconds. And that 12 does not have a label, so what is it? If it doesn't have a label, what is it?
Feet.
Radians, radians. So if I look at number 2, if I take 12 divided by 1.6, my answer should be radians, which is what I put, per second. See how I'm doing this? Test, scrap paper. This is what it should look like. Some of you didn't include numbers or box in your answers or any of that kind of stuff. Yeah. Yeah. All right, let's jump around. Let's do, all right, let's do number 6. Let's try number 6. Number 6. A pulley of radius 25 centimeters. I'm looking for some partial credit, if nothing else. Radius equals 25 centimeters. Rotates 7 times per second rotates 7 times per second. Whoa, 7 times. If it rotates 7 times, that's like a revolution, right? So if I clean this up, I'm thinking that this is going to be going around. How far around is it one time?
360.
2 pi.
2 pi. So if I go around 7 times, it's going to be 14 pi over 1 second. Now, what is that? What is this? This is the angle measure in terms of time. So that means what letter is that? The change in angle over the change in time. That was my angular speed. That guy right there, which well, that's my W. That's my W. The change in the angle over time. Angular speed. Ah, you're a smart professor, I know. So this now says, find the angular speed. Oh, where are we at here? I'm sorry. I was reading the wrong one. Time, oh, in 4 seconds. Rotate 7 times in 4 seconds. I'm sorry. So this should be, why didn't anyone correct me? In 4 seconds. So this would be 14 pi over 4. Let's go back and take another look at it. A pulley of radius 25 centimeters rotates 7 times in 4 seconds. What is the angular speed of the pulley? Well, the 25 had really nothing to do with it, did it? Because it wanted angular speed, and that's what this guy becomes. 7 pi over 2 seconds. So I didn't even need to know the radius. We have a number 7 and we have a number 8. Pick one, 7 or 8.
8.
8.
8.
8. A wheel is rotating at 4 radians per second. A wheel, I have a wheel, is rotating at 4 radians per second. What's that the formula for? What is that? Equals what letter?
W.
W. Yeah, excellent. W. The change in angle over the change in time. The wheel has a 96-inch diameter. Diameter is all the way across, 96 inches, which means this is now going to have a radius of
33.
half
wait. 43.
48 inches. Okay, 48 inches. To the nearest foot per minute. No, wait a minute. I want a foot per minute. Okay, what's foot per minute? Feet is a length, right? So if I do the length in terms of time, that's my what letter?
S.
Not S. No, this is in terms of time. V, right? This is my linear speed. So now this is what I want to calculate. This is what I have. This is what I have. And I got excited because this is that mutated formula. What do you mean by that? It was the mutated formula. Again, I'm going to write my formulas down. S equals theta R. V linear speed was S over T, right? Distance. So this is all, yeah. W was angle measure over T. And I went and I did that instead of the S, I'm going to put theta R over T. And then I can pull the theta T out. V equals WR. So when I want to find V foot per minute, I'm going to use my W, 4 radians per 1 second, times my radius, 48 inches. We're getting close. We're getting close. So I'm going to multiply. Radians times inches, the radians just disappear. So in my numerator, I'm going to have inches. 4 times 48, 192. And it looks like I might be done, but I'm not. Why? Because I need to be in terms of feet. And I'm in terms of inches. That's okay, because I know 12 inches is the same as 1 foot. The labels cancel, inches and inches. So now I have 192 feet over 12 seconds. I'm getting closer because I need minutes now. I need minutes. So just like I did a 60 seconds, I'm going to do another conversion, is the same as 1 minute. So now my second labels cancel, and I'm going to have, oh boy, 192 times 60. I love this problem. 192 times 60 is 11520. Let's see, the seconds were canceled. So this is feet over, again, the seconds were canceled, 12 minutes. And I guess I should probably divide that by 12, and I get 960 feet per minute. Nicely done. I started writing down what I had from the problem, figured out what I needed to calculate. I had my formulas. I can remember these formulas. This one down here, yeah, I put theta over R in for S. And then in terms of theta over T, I put W. And again, I could be memorizing linear speed equals angular speed times radius. But so I got so far to here, and then I went, uh-oh, I have an answer, but it's inches per second, not feet per minute. So I had to keep doing some conversions. I got rid of the inches and made feet. I got rid of the seconds and made minutes.